All right, let's get started. My name is Ryan Stroop, and I'm hosting this series on fault detection and diagnostic tools. I work out of the PG&E Energy Centers in Northern California, and I focus on classes related to existing buildings, including trainings on energy audits, building commissioning, and measurement. And this fault detection and diagnostic series grew out of a workshop we did in the fall on the topic with several speakers from different national labs. And now we're getting a series of software demonstrations, and I'll go through the full schedule here in just a minute. So let me start by acknowledging a few little details. There is a disclaimer, and the session is being recorded. What's noteworthy here for folks that are attending is if you have questions that are submitted and you can't attend through the end of the session, we will address all questions. You can always access the recording to get the answer to your question. And all of the sessions in this series will be made available as recordings on our on-demand platform. So you can look for those. As for safety, please have an egress path, a means of getting out where you're attending today. If that path is blocked, you need the second means of egress. So you should have two paths out. Sort of a common safety procedure, especially with earthquake country in California, you might have a path blocked. You should have a place where you're going to meet whomever you're residing with, family, loved ones, that's all set up in advance. You may not be able to communicate it in an emergency, so have that location established and rehearsed. Have a go bag prepared. A go bag includes essentials you'd need in an emergency: first aid kit, medicine, short supply of food and water, change of clothes, flashlight with new batteries. You can Google go bag to get more information. In case of an earthquake, duck, cover, and hold. Go under your desk. Wait for the building to stop shaking before you surface. We don't recommend people exit a building during an earthquake or shortly after an earthquake, because you could be in the path of falling glass. Remember, the pandemic is ongoing. I know mandates are changing, but we're still advocating that people wear a mask in public, wash your hands regularly, and maintain social distance. And finally, this is only an hour-long session, but stop, stretch, and take ergonomic breaks as needed. I want to acknowledge the California chapter of the Building Commissioning Association, who helped us promote this series on fault detection and diagnostic tools. You can learn more about the Building Commissioning Association, a conference they put on every year, the trainings they offer. Become a member if you're in the commissioning industry. And then this is the series of demonstrations. We're actually at the halfway point. This session will be the 8th of 14 today, and you can see the schedule. There's at least two for the following 3 weeks, and that will wrap us up. So we have 7 more, including today's. So with that, Spiros, I'm going to make you, let's see. Oh, I want to mention questions real quick. So we're going to ask you to type in your questions as they occur to you. I will ask Spiros to address the questions at the end, and we will sort of add a little extra time at the end for Q&A. If you have to leave at 1 o'clock, again, you can always see the answer to your question in the chat, or in the recording, I should say, that's available after the event is concluded. And there is a PDF of the slides available in the handouts link, and I'll put other information in the chat. I'll send you some other additional details as we go here. So here's, I'm going to make you the presenter, and I'll let you know when I can see your screen. In the meantime, introduce our speaker for today's demonstration. So Spiros Sakhareliadis joined ICONICS in June 2021 after an 18-year career at Microsoft. He is a subject matter expert about fault detection and diagnostics for Microsoft customer community and Microsoft's own 770 facilities worldwide. In 2011, Spiros began working with the Internet of Things technologies and co-authored multiple patents on the Internet of Things gateways. From there, he moved over to Azure Machine Learning Product Group, focusing on ML models and anomaly detection for buildings and citywide infrastructures. and then into a customer-facing role in the smart buildings team. Spiros advised building owners on how to use telemetry data from facilities and environment to address issues such as malfunctioning or poorly configured systems, safety, comfort, sustainability, and overall efficient operation. Spiros is an experienced business and technology professional with a passion for developing innovative technology solutions for new markets. Spiros, I see you. I see your slides. Just do an audio check and you're good to go.
Good. Can you hear me?
And I hear you. Yep.
Excellent.
Thanks for doing this.
Well, I think, Ryan, you said everything that there is to be said about me. We can go straight to the Q&A. All right. So that said, let's jump into the slides. I'm happy to be here and happy to be working on with you on this. The list of other presenters was kind of daunting, so hope we can address at least as much detail as you're expecting. So that said, let us move on. I have a few introductory slides. First is, what is ICONICS? ICONICS basically is a company that writes and publishes software. We're an ISV in that sense. We're not an SI. We don't operate software. We don't do anything other than write software, although of course we have a consulting team that can help deploy or troubleshoot, and we have 24/7 support. Now this software is used by, well, we've been in business for about 30 years or so. This software is used in multiple industries. Essentially, it's a software that can be tailored to get data regardless of your industry, from devices or equipment or environments, identify issues and lead you to fix them, right? So it's industry agnostic, and its main task is to be able to monitor equipment, devices, environments, and so on, and to be able to manage those. So it can read the data, it can write back to the data, and so on. Let me turn off my camera. It's in some sense a middleware that allows you to configure to get data from essentially anything that produces data and send commands back to it. Once you have the data, of course, you've got to be able to do something with it, and our software allows you to display the data, display real-time data from your devices, display it in many different ways, allows you to historize the data and display the historical information. And once you've displayed it or seen the data and got the history, the most important aspect is being able to identify what's a problem. So the software has modules that allow you to detect issues, whether they are small little issues like, I don't know, maybe the room's slightly too hot, or maybe they're serious problems like there's someone that's about to fall into off the edge of a building, or more serious issues with respect to energy consumption and so on. And then once we've been able to diagnose the problems, we need to be able to raise alarms to send issues, whether it's by email or SMS or pagers, so on, to alert people to do something, as well as integrate into other systems like CMMSs and so on. All of this, right, is basically for the purpose of doing something to improve the state of affairs. And so, for example, to reduce your energy consumption. Our software has been in use on the Microsoft campus or on the Microsoft campuses worldwide. Here's an example of what using a remote management monitoring management system does. This is one building on the Microsoft campus, monitoring the kilowatt hours consumed from January of 2011 to the end of December 2020. And the only thing that happened here in March of 2013 was adding the ICONICS software. Statistically relevant events, right? Now this is for the entire campus, saving between 25 and 30% on energy. Now saving energy, of course, is just one of the potential outcomes and the reasons you would implement software like the ICONICS suite. But it could be other things. It could be related to comfort. It could be related to labor efficiency. It could be related to security and so on. That said, let's move straight into a demo. In this case, what I want to show you was just a quick demo of a company called the International Union of Operating Engineers. I'm assuming you can see this.
Yes, we see it.
The IUOE, name I always mispronounce, is a facility that trains union members in the use of heavy equipment. But they also train them in managing the building and so on. And they have an implementation of the ICONICS software, which is used on this building, right? But the people who are in the building are members of the IUOE, being trained to use things like these bulldozers and cranes and so on. They're all happy, smiling people. And so what I want to show you is the dashboard, the ICONICS dashboard that they use at IUOE. And start with the home page. This is the overview of the various systems that they have in place. Now, this probably looks very similar to what you've seen from many other companies in the space, and we'll see for the next 7 slides and so on, is a nice colorful page with lots of different charts and symbols and so on. But ultimately, here are some of the things that they look at the top on a daily basis. You can drill down on a lot of these. So, for example, they're interested in what the comfort is of the building, and these are, they've defined a comfort thing as the amount of time that the temperature of a room is in between the low and the high set points. And they're measuring things like fresh air changes, the air quality like CO2 and so on. On a more typical thing that you'll have seen from a number of companies in this space relates to fault detection. They are looking at all the different faults that they're detecting, and we'll go through how ICONICS does that later. But for any one of these things, let's see if we can click on the details. Anyone? We can click on the details of the equipment and see data about the equipment and why there's a problem, and somewhere along the lines, an engineer would be able to identify what the potential cause is of that problem. They're also looking at it in a slightly different view. For example, they might be looking at a floor plan. Within that floor plan, they can put in overlays. So, for example, in this overlay here, we can see, keep zooming in, the temperature of the rooms and so on. You could have an overlay of, actually, wait, let's go to temperature. You could have overlays of faults. You could have overlays of occupancy, overlays of air quality, and so on. It's just up to whatever the company wants to put in. If it's an engineer working on the chilled water system, they can get different types of views where they're seeing diagrams of the equipment, they're seeing current values, and so on. There's the cold water. Here's the hot water. And again, these are all controls that we have within ICONICS with the real-time data being shown there. Of course, one of the things that they're interested in is, what's the energy consumption? We can look at the energy consumption over time. This is all the straightforward use of data from the environment, from the equipment, and so on they're getting, and maybe they're drilling down to specific, in this case, air handlers and so on. That's a very typical use of ICONICS software. And so what I wanted to do was take you through a little bit more about what it is that how we use the ICONICS software in this environment and how to set it up. So the first aspect of all this is data collection, and in terms of things that produce data, they range, of course, from legacy pieces of equipment that are connected to, I don't know, PLCs or to building management systems and so on. There are modern devices which send data up through using protocols like MQTT or having Microsoft Azure Sphere embedded in it, which sends data using AMQP to the cloud. There are proprietary devices that talk to some third-party web service and so on. In terms of on-premise, ICONICS really has two offerings. One is its ICONICS Suite, the other, known as Genesis 64, and the other is IoT Works, which is a trimmed-down version that runs on a small footprint on something called IoT Edge. But the basic idea is you've got something that talks to equipment and using standard protocols, like in this case, the protocols out of the box are things like BACnet, Modbus, OPC UA, and so on. And using third-party modules like one we have from a company called Takabishi can talk to many different industrial PLCs. Now, what I want to show you is how you configure that in our software. So in this case here, I'm going to access a virtual machine. It's running on a small Intel device, and I've installed the ICONICS suite on this. When you install ICONICS, you can install it with an MSI, with the Azure Marketplace. It installs a series of modules, it installs a bunch of tools, and it installs a boatload of services in the Windows service. I don't know if you can see these. Let me look at the audience view. Yeah, so these are a bunch of ICONICS services that are installed and running when you launch and install the ICONICS product. Now, the product that we're going to use to configure all this is something called Workbench, and I have an instance of it here running. So what Workbench does is it allows you to configure the software in many different aspects, and during this presentation, I'm going to show you bits and pieces of it. So data connectivity to talk to devices, you look at the data connectivity module, and within that, depending on what protocols you've installed, I've installed BACnet, and I've told it that I have an occupancy sensor running on my local network. If I do a network scan for devices on there, network discovery, I would discover all the things that were on there, and in this case, it discovered that I have this occupancy sensor, and on the occupancy sensor, it discovered a huge number of objects that sensor is actually publishing or responding to queries on. So, for example, if I look at the sound level, it'll show me what the data is, and right now the sound level is somewhere between 30 and 50 decibels. So that's basically the process of configuring the access to the data. Now I have another tool called the Data Explorer, which I can look at to see what data is coming in. And in this case here, I can browse down to the same thing, and I can go down and look at, and I was looking at, where was it? The present value for the sound. So the very first step is to decide, what it is you are going to get data from. And in our case, in my case here, what I've done is I've pulled data from a lot of different devices. One device with a lot of different objects on it. And now what I'm going to do is I'm going to show you how to see that data. And for that, again, in the same tool, I would now bring up this thing called GraphWorks, in which I get to create a screen. I get to add a lot of different types of controls to it. In this case, I'm going to show you I've added a control that has some gauges for the current values and some trends. So I've added those. So for example, to keep on the sound level one, what I've done is I've created a pen that gets data from the of the history, and I've created a gauge that gets me the current value. If I want to look at this, I go into runtime, and this is a preview, and it shows me this data. But a preview here is not as interesting as if I bring up a browser. Here's a browser on my laptop that I'm seeing this data as it's published. So in this case, I've got the current values here. Temperature in my room is 70 degrees, humidity is 48%, and the sound level depends on how loudly I'm speaking. Let me see if I clap my hands. Notice it goes, whoa, that was a pretty loud clap. So again, I can change what I'm displaying, how what the ranges are, and so on. It's basically completely configurable. So going back to this out of my thing, I've been able to get the data from any object, and it's completely scalable. So for example, on the Microsoft campus, which I worked on for many years, we were pulling data from 450,000 different data points into the ICONICS system. Now, so the question is, what do you then do with the data? You saw some screens from my UOE about faults and so on. There are, basically, the issue is how to tell from the data from all these different devices and environments that something is not the way it should be or the way you want it to be. These can go from very simple things like the room is too hot, meaning you're comparing a current value to some sort of constant that you set. The air quality is terrible or something like that. Or it could be something slightly more complex, like the water pressure coming out of the tap is too low to fill your bathtub in the amount of time that you're willing to wait. Or an industrial environment that the air pressure is not sufficient to push enough air through the room for the number of people that are in it. And it can then go up to very complex, different types of things you're looking at. The relationship between 7 or 8 or 10 different variables to make sure that some system is operating efficiently. Now within ICONICS, we have numbers of ways of doing this. The simple type expressions are through this thing we call the hyper alarm server, which are purely sort of OPC type alarms, and then more complex ones through this module we call FDDWorks and the associated library that we call Facility AnalytiX. So let me show you some of this. So alarms, and for that I will go back to this character here, and what I will do is bring up my configuration, and instead of going to data connectivity, I will go to alarms. And in the alarm server, I can create areas. In this case, what I'm showing you is my home office. And for example, I've created an alarm on sound. And I just call it something. The input I've done is I've taken the BACnet data point, which I showed you earlier, and I said if the sound is over 30 decibels, display this alarm, right? If it's not go back to saying this is fine. This is a very simple, what we call a limit alarm, which is essentially one data point against a limit. Another example of a limit alarm would be I'm looking at humidity, and I'm saying if the humidity is more than 60%, it's too high for comfort. Now, the way that that we do this is we can create more complex ones, and this is a case where there are 3 different levels. If it's essentially 0, then, or if it's below 20, we say it's too low. If it's above 50, we say it's too high. Anywhere else, it's normal. And so that's an example of a different type of alarm. We can create these things where, so the basic ones you get when you install it are a digital and a limit type, which are instantiated whenever you create one here, but you can create many different types. If we look at a limit type, the expression is simply, it's an if-then thing that says, if the data is higher than a certain value, then you've got an alarm. Right? So that was the limit for sound level is greater than this, or humidity is greater than that. A digital type says if a logical expression is something or other, then it's a, sorry, what I wanted was this one. This one says if a logical expression evaluates as true, then issue that alarm. Otherwise, if this logical expression is true, issue a different alarm. So we can start creating different types of alarms based on essentially different types of logic. And these are the simple ones. If I go to the viewer again, and I look at alarms, let's put this one into runtime, and I go to alarms. Whoops, I had hidden them all. Let me go back to unhiding them. I want to see all of these guys. All right, so we're in the viewer again. This time I want to see alarms. Here is the alarm that I created that says let's see if I can zoom in on this. Ooh, maybe that's too much of a zoom. Maybe I can zoom in a bit less. All right, so here's the alarm you saw me create by clapping my hands. Here's a log of different alarms. You notice it went to this. Before that, it was at an acceptable level, but the actual alarms I'm getting are these ones here. And again, if I want to see that in just a browser, I can go to this, and this is now just the browser that I could see remotely over the internet or anywhere else. All right. So simple alarms are ones in which you essentially create you pick an alarm type, you decide whether that's going to have a simple input of some sort of variable against a constant or a more complex one. In this case, marginally more complex. If it goes below 20, it's one thing. If it goes above 50, it's another. But then they can be extremely complex. Now, one of the things I want to do then is show you what happens if you exceed the complexity that we have there, and that's what we call fault detection. And going back to our workbench, what we have is we have a module called Analytics, which contains modules that you create, and our digital twin, which is called AssetWorks. And in this case, there's a digital twin of the occupancy sensor with these data on it. But notice there's a tab here called FDDWorks. when I click that one, I can say, okay, for that asset, I can create a whole bunch of different types of alarms. So a simple alarm is an alarm in a data stream. More complex, you would define alarms by assets. So all the assets, all the instances of this occupancy sensor, you could apply these faults to. And in this case here, I've created two sets of faults. So if we take a look at, for example, this one here, the fault rule for that was that if the occupancy, which is a measure of the sound level, if that is in alarm for more than 1 minute, then set an alarm. So this simple fault rule simply is adding a time specification. It's not just there's an alarm now, but it's rather if this thing has been alarming for a whole minute, then there is a fault. My room 2 hot one is very similar. It just says if the temperature is greater than 15 Celsius for more than 15 seconds, issue a fault. So again, in this case, what we've got is going back to the to this guy here, the faults. Notice I'm getting a fault, and it tells me what time the fault started and how long it's been going on. You saw that in the IUOE example, where the facility had dozens of different faults defined against their different assets, and they were able to look at a page and said, you know, what's in fault where. Now these faults can be set up to be acknowledged, not acknowledged, and so on. But ultimately, what you've got is essentially an example where if it's a relatively simple expression that you want to use to define if there's a problem, you can do it as an alarm, and the alarms can get relatively complex. If you want to define it against an asset class, then or an asset itself, then you would define it in FDDWorks, and for those you can create much more complex algorithms, and you can see here that you've got a lot of ability to add in operators and so on for doing that. In general, the other nice thing about FDDWorks is that you can define a cost of a fault. I don't have one here, but the cost of a fault can be defined as, for example, how much energy is it wasting? So for if that fault is active for 20 minutes, maybe you're wasting 3 kilowatts of energy. Or it could be if the fault is around for 1 day, the cost is expressed in the number of user complaints that you're going to get. So there are many different ways to calculate and represent faults, but ultimately the idea is that the operator wants to have a dashboard that shows them what types of problems exist and recommend potentially what to do about it. So when we look at, in my case here, let's go back to the dashboard. One of the things that you notice, I've got this fault, but within the fault model, it's telling me that the 60% chance of the fault was created by my dog barking, 30% chance by someone talking behind me, 10% chance by, I've got the Spotify playing. That's again a very simple example, but the idea is that within the fault, we get to apply a fault module, a fault diagnostic module. And in this case here, I've created a diagnostic module that says if this fault is raised, here are the potential causes. Now this is a very simple version. We can do much more complex ones where you're pushing the fault into an AI or an ML model that comes up with far more sophisticated diagnoses. But generally speaking, most faults don't require AI or ML to come up with a potential root cause. And the engineers who are setting this up can say, okay, when that happens, 9 times out of 10, the fan belt has broken or something. Now, within all that, let's go back to this. We've configured alarms, we configured more complex faults, but the question is, we're doing all this at the moment on a box that's on-premise on a local network. One of the things that we find a lot is that we have customers that want to push all this to the cloud for scalability purposes. Maybe like Microsoft, they have facilities all around the world, or oil companies who have rigs all over the ocean, and so on. So what we have is the ability to take all these different sites and push them up into the cloud. So in this case, what I'll show you is the stuff I've just been talking about. We have modules within the ICONICS suite that can allow you to push it to the cloud, and then in the cloud, the ability to subscribe to that data and do stuff with it. So let's talk about pushing to the cloud. So here we have the same workbench, and what I want to do now is go into the IoT module, and the first thing I want to do is say, well, what am I going to publish? So I can create what's called a publish list. I can create as many publish lists as I want. And on this publish list, I can decide what it is I am going to include in that publish list. I can decide whether it's a writable point to or not. And I can also publish alarms. So in this case, I'm publishing data streams. In this case, I'm publishing just alarms. And within that, I can decide how I'm going to encode the data and where I'm going to send it to. So I can create multiple different publisher connections. In this case, I have one that's going to Azure IoT Hub. It's using this connector, this encoder, and it's going to send it to this location. For the publish list, I can say how often it's going to get published and so on. For the data connectivity, I can say how often it's going to be collected. For the publisher, I decide how often it's going to be sent. So this is sending it up to the cloud. And in this case here, what I will do is I will show it to you. Here it is using something called a Microsoft tool called IoT Explorer. And what I'm looking at is simply data coming into the cloud from the device. So this is the first thing here moving into IoT. This is the data encoded in the way I said it should be encoded, moving up into the cloud. So now the question is, how do I get the data? So instead of going into my VM where I was publishing the data, I'm going to go to a VM in the cloud up in Azure. And here I will say, okay, I'm going to create a subscriber connection under the Internet of Things. And I'm going to create a subscriber connection to the IoT Hub. And I'm using some connection strings to get it. So at this point in time, I can go into this thing called Data Explorer, go down, look at my subscriber, look at the gateway that I created, look at the data that's coming in, and here is the data. Now I'm in the cloud receiving the data that was sent up by the gateway. If I'm over here, I'm seeing the alarms that were sent. If I'm down here, I'm seeing the data that was sent. So essentially, I've subscribed to that data. Now the question is, what am I going to do with it? And here's the stuff that I decide to collect and send. I've subscribed to it. Now I can use any of the various different modules within ICONICS to pull the data together. We've got the same things before. GraphWorks to look at it. FDD works if you want to do more complex fault detection, the alarm server, and so on. So everything we did locally there, we can do here in the cloud. I'll show you the quick difference on that. So I've gone to, again, the cloud version. In this case here, I bring up the same tool. And the difference is that, look, I'm looking here, for example, at the alarm. So let me hide defaults. I'm looking at the alarms. Oops, let me hide the alarms too. I'm looking just at the trends and so on. The difference is that instead of having the backnet protocol, what I'm doing is I'm going to the alarm server protocol that I'm getting it from. So let me bring up a dashboard. This is now the dashboard in Azure. If I've got a nice blue thing here, let me get onto the side. And here's the dashboard when I'm looking at the local server on the gateway on premise. Here is the dashboard when I'm looking at it in the cloud. Here is my local trends, alarms, and so on. Here is the same data being alarmed here. I created a slightly different alarm, but I'm pulling it from the same data. Notice, here it says the temperature. I'm looking at the same temperature when I see it in the cloud. Humidity, temperature, sound level, and so on. And I'm looking at the alarms that I'm sending up, and I'm looking at the faults. Basically, this is doing everything on premise. And on the right here, I'm pulling stuff from, I'm publishing it to the cloud, and I may be looking at, instead of over here, I'm looking at, say, at one site. Here, I might be looking at 100 different sites and aggregating them all there. So the IoT aspect of it is essentially if you want to scale and connect it to many different things. So in this case here, one of the last things I want to mention is connecting. So now you've got it into the cloud, as well as doing all your standard ICONICS things. One of the things our clients are doing a lot is connecting it to ERP systems or CRM systems or other type of decision-making systems. In this case, those same faults were pushed into Microsoft Dynamics 365 field service for work order management. And again, the whole point here is that on-premise stuff you're doing is typically reacting to specific events and doing things and seeing the status of them or that equipment. If you're in an IoT environment, you're looking, amongst other things, around a much larger set of problems, much larger set of sites, and want to do some remote management and some work order management and so on. So that brings me to the 43 minutes. So I got 2 minutes. I'm 2 minutes ahead of schedule. But so with that, let's turn it over to Ryan for some Q&A.
Great, Spiros. So, folks, if you've got questions, please submit them. We have a handful of questions, but we have plenty of time for your questions. First question, Spiros, are the system displays overlays standard or an option?
Think of it as just a software for creating displays, and all those controls and so on are things that you get standard that you drag and drop onto your canvas and you pick your data source. There are some pre-configured ones, but generally speaking, it's up to the user to define what they want their dashboards to look like.
So I guess it may be a follow-up question, anticipating a follow-up question. How much customization do you sort of embed in your projects then?
It really depends on how complex the project is. So in the thing I was showing you, which is the dashboard for my home occupancy sensor, that was probably 2-3 hours worth of me deciding on the colors and what widgets I wanted and making sure I was pulling the right data streams. In the case that I was involved with on the Microsoft premise, where they had 770 buildings worldwide, 30,000 pieces of equipment on the Redmond campus alone, that was, a lot of customization. So, you know, I hate to say it, but it depends.
Yeah.
Your
Right.
mileage may vary. But it's very simple to get something up and started quickly. And then, of course, everyone gets in their 2 cents and wants more and more complex and so on.
Okay. I'm going to move to the next question. And so, Kyle, if you want more clarification there, please type in a follow-up. Does ICONICS work with variable refrigerant flow systems?
I can find you the answer to that. To me, it's ICONICS works with anything that can produce data using a standard protocol, BACnet, Modbus, and so on, OPC UA. And also there are add-in device driver modules for various things. I know we have clients in the food service industry that have got refrigerated environments, refrigerated trucks, and so on. I don't know the details. If you send me an email, I can get you more information.
Yeah, and Spirits' email is there on the screen. Next question, what programming language is used for the fault and alarm programming modules?
So it's euphemistically a no-code thing, but obviously it is basically when you go into the workbench, you get to click on essentially what operators you want. And so in this case here, I'm picking if-then statements, I'm picking various things here. There is a coding interface. Again, I'm not the person to tell you that, but the majority of our customers, the vast majority, are just using the no-code version where they're picking controls and picking operators from the options shown there.
Okay. So, folks, we have plenty of time for questions. If you have them, please submit them. What percentage of your clients keep data locally versus pushing the data to the cloud?
So given that we've been in business for 35 years and have 375,000 clients, I would say that 99% of them keep data locally, right? Because pushing to the cloud is the last 3 or 4 years worth of customers. And then we do have a lot of customers that had previously kept everything locally that are now pushing to the cloud. The reasons for pushing to the cloud in general, independent of ICONICS, right, are all the standard reasons why the cloud in general is getting increasing adoption, whether that's scalability, reliability, cost, and so on. What I can say is that it varies by industry. Financial services has a different sensitivity to the cloud than manufacturing, which has a different sensitivity than infrastructure and buildings and so on. Also, the question is, what do you want to keep locally and what do you want to display at the cloud? Are you doing it for redundancy? Are you doing it for reporting purposes? And so on. So again, your mileage may vary, but in general, I would say that I'm speaking off the top of my head because I don't have visibility into what all our salespeople are saying, but certainly of the opportunities I see on a weekly basis, probably half are wanting to currently do it on-premise only, and half are want to do it in the cloud. And of the ones that want to do it on-premise, about half of those are saying that they will never go to the cloud, and the other half are saying that they want to start with doing it on-premise and then move to the cloud.
I see.
But the statistics, if you quote me on them, I'm sort of pulling them out of a hat.
Sure. Sure. So just a couple reminders, folks. You still have time to submit your questions, and I put the evaluation link in the chat for this session, and your feedback on these is welcome and encouraged. Next question, what are the minimum hardware requirements to run the application locally, excluding storage requirements for data?
So if you're going to run everything on premise, you've got the options of the amount of power you need. It depends on how many modules you want to run. It also depends on how much data you're collecting, whether you're collecting 1,000 points every second, or you're collecting 50,000 points every 5 minutes. It depends on the size of the data and so on. We've got notes and tables of what are the essentially the performance requirements, or the performance stacks for different sizes of hardware and so on. If you're pushing it to the cloud, then your scalability again depends on the number of messages you're sending, the amount you're storing. If you look at, for example, just IoT Hub, you can scale that up in terms of the number of messages per second, almost infinitely to the billions of messages received per day or higher. Again, with the ICONICS software in the cloud, what you're doing is you're essentially architecting the system with additional modules or virtual machines based upon how much you're doing. So maybe if you've got 5 buildings, you only have 1 I/O server. If you've got 125 buildings, maybe you have 8 I/O servers. So it really is it's a case where it depends on the amount of data, the frequency of the data, and so on. The smallest on-site thing, well, I mean, just to give you an example, the thing I was showing you was running on a small Intel NUC that I bought off Amazon for $200. We're looking at going into much smaller devices, small industrial gateways. I don't know what the smallest is, but if you look at our website, you can see the published specs, which means we've tested it down to this level. It doesn't mean that your mileage may vary, and you might be able to do it on a smaller machine.
Okay. Sort of a related question, Spiros. The software offers a lot of customization, but setting up a large portfolio might take a lot of time. What kind of automation does the software offer to speed up deployments? How can I find the root cause when the fault involves multiple systems and devices?
Yes, so you're totally correct that it's all about customization. We have sort of starter systems to pull it together and be able to be up and running very quickly in terms of a proof of concept. And then as you want to push it through to get much more sophisticated, building up fault rules. I mean, there are companies that have a library of, oh, I didn't show you, sorry, let me just jump in, I got a second here. Can you still see my screen?
Yeah, yes, we can.
When we go to under assets, right? Asset classes. So when you get install the Facility AnalytiX library, it gives you a series of classes of equipment for a quick start to reduce the time to deploy. And for each one of these, so for example, one of these, it'll give you a whole bunch of custom fault rules that you can then use and so on. So these are some way more complex fault rules. So this is the Facility Analytics module, which gives you a jump start for buildings and facilities that allow you to much more quickly implement something that starts to identify what's wrong in the system, as opposed to having to write all those things directly from scratch yourself.
That's nice to see. I'm glad you showed an example of something from your fault library. So do you roll out the fault library in its sort of complete list of faults to every site, or do customers sort of pick and choose the faults that they want? How does that work?
So in general, people tend to use this as examples and pick and choose, because everyone's going to have a slightly different. Let's see if we can pick one of these things. Everyone's going to have a slightly different way of defining the fault and so on. So this tends to be a template that people use to modify, as opposed to just apply it, because every manufacturer's fan coil unit FCU is going to be different, right? And some will have this variable that it exposes, or this point that exposes, others won't. So this is very much a template, but it gives you a great start for in this case, for buildings.
Okay. Do you have any idea how many faults you have in your library?
No. I do know that one large customer I was working with had a fault library of about 3,500 rules. But many of those are tweaks on the same rule, right?
Yeah.
So, I mean, they may have 30 different versions of the FCU fault for occupied set point, because, two different manufacturers might have two different things. And, let's say they had a rooftop unit on 100 different buildings, but that might require, 20 different sets of fault rules, because the slight differences in the ages and configurations of the RTUs. But small environments or for straightforward things which send out a huge quantity of data but not many data points, you might have 10 fault rules. For large clients on huge facilities with tens of thousands of pieces of equipment, you might have, in the end, you might have 1,000 or more fault rules.
I see. Okay. Next question. Can you talk about the 24/7 support that you mentioned? How does that work?
How does it work? Well, if you contract with ICONICS for, I think we call it support works, then you're able to call in and work with engineers to solve your fault. I mean, to solve your problem. I don't know much more about than that, but I know that there's a 24/7, level 1 through level 3 support team, and it's global, right? Whether it's in Japan, because amongst other things, we are a group company of Mitsubishi Electric, so we have a very strong presence in Asia. But the software can be deployed in many different languages, localized. Support is available in all regions, or at least most regions.
Yeah. So I think a natural follow-up to that is to have you talk, Spears, a little bit about the business model. So you license the product, and then there's a fee for service support. Is that how it works, or is it different?
I'm, in truth, the wrong person to ask about licensing. There are different licensing models. They range from ones where you're licensing by the number of tags, and so on. But again, I would have to put you in touch with someone in the sales team that can talk to you about the different licensing models and the perpetual versus the subscription and the how they scale and so on.
Okay. Next question, is there a meter library like the building automation?
A meter library.
Well, I'm thinking that since I've seen a number of these, Kyle, correct me if I'm off base with what I'm assuming you're referring to. So what I'm thinking is meter library, like utility meters that you're also tracking as part of your interface. So like you're tracking electricity, you're tracking natural gas, you're able to set benchmarks. Kyle, type in if I'm off base there, if I'm interpreting meter library differently than the way you're interpreting.
So I have not seen a meter library, but I do know that. So I've implemented systems which are, for example, monitoring all the Schneider power meters in a campus, pulling in the data from them and comparing that to over time. And you saw in the IUOE example how they were monitoring all the kilowatt hours from monitoring the power meters, whether they're Schneider or a Siemens or another company. But I haven't seen something the equivalent of facility analytics for other types of equipment. Now, as part of our integration with Mitsubishi Electric and a vendor by the name of Tekabishi, we do have the ability to read huge quantities of industrial equipment protocols, and there are quite possibly libraries within those. Again, if you send me a specific question, I can get an answer to that.
So the questioner gave me two clarifications. He says under equipment class, is there a meter library? And then he's looking for pre-built modules.
Yeah,
for different equipment classes, like meters for flow, I guess, meters for
so here are some of the standard ones that come with our samples library. For electric meter, let's see what it has here under the classes. It has, you can set it as an alarm. Again, I haven't worked with any of these, so I can try and get that information for you, but I don't have any direct knowledge of them.
So folks, you can, again, Spiris's email address is in the slide deck. You could also put it in the chat if you want, Spiros, that way people have it.
Yeah.
Let me go to the next question.
Chat, send a message to
everyone,
the
entire audience.
And type here.
Then again, we are going to go over with your question. So if you have if you've been sitting on a question, please type it in. And I just saw your he just put his email address in the chat. You guys should all see it in what is essentially your question interface. Next question. Do you have a database of algorithms to calculate fault cost savings? So energy, financial savings. For example, a supplier temperature reset to calculate the energy savings from that as a fault. The reset's not working. Here's the potential benefit from an energy and dollar standpoint.
So we have implemented a lot of those. I don't have a specific library I can point to. Again, I'm going to give you the non-answer, and that is send it to me. I'll try and find out. But the examples that I've actually implemented and used myself uh, the the fault costs um, are usually based upon the building engineers or the equipment engineers at a site.
Okay. So I think we've exhausted the questions from attendees. So I'm going to interject a couple, but we have time, folks. If you have questions for Spiros, please type them in. Spiros, I think it was helpful to see the fault that was a little bit more elaborate than the one that you showed, on sound and occupancy, just to see the complexity. So that was helpful. I was going to ask you to do that, and you did that. But could you talk about an implementation challenge that you've experienced with your platform that has translated into some product feature?
Sure. So there are a never-ending series of those. So it's the modern world where you're issuing updates and alerts and feature adds on a very rapid cadence due to customer requests. But for example, the thing I mentioned a few times is customers have asked for protocols other than BACnet, Modbus, OPC UA, and so on. So we worked with Takebishi to add about several dozen proprietary protocols for pieces of equipment. We had customers that wanted integration to CMMS systems. So a company in the Pacific Northwest called McDonnell Miller wanted to integrate into Dynamics Field Service. So we developed some modules to allow easy integration to CMMSs, and in that case, specifically to Microsoft's Dynamics Field Service. Another recent one is what I showed you with respect to the on-premise device. You notice I had RDP'd into the device. Where we had a lot of customers that saying they didn't allow remote access into the units in the field. So we developed the product, the SKU we call IoT Works, which you configure from the cloud in a pub/sub method, so you don't have to RDP into a remote unit to be able to configure the publishing and the alarming and so on. So, and it's a continuous basis, right there, especially when you've been in business for as long as we have. Scenarios and devices come online at rates that you never dreamt of 10 years ago.
Got it. Can you talk about how the faults are documented? I know you showed, is there like an issues list, or is there some sort of tracking that, does it get translated into work orders? What does the fault documentation look like?
So you can do any of that, right? If you notice, there were there are loggers. In the case of the alarms, there's a hyper alarm logger where you can be logging it. For FTD Works, there's a fault logger. So you can log it at all different levels, and these are logs mostly for the operating engineers. You can also log it at debugging level. We have a tool called TraceWorks that ships with the system, where you can be logging, under the hood for debugging issues. But standardly speaking, whether you're talking about raw data, alarms, faults, and so on, we have these loggers. And if you look here, we have this thing called the hyperhistorian, in which you can decide you are going to historize anything at any different level. And in general, this is the ability to store data, and I've seen cases where these logs, this historian goes into the massive amounts of data for 5-10 years. We also then are able to, in real time, push from our hyperhistorian into, for example, Azure Data Lake or SQL Server or a NoSQL database. So as well as having our own historian, which you use. So for example, when I showed you the trends, when I showed you, we went here and we are looking at trends of data. This is coming from the historian. This is real-time data coming in, which I'm then pushing it to the historian, and then this data is all coming from querying the historian, and that can be as you can be looking at very near time things like over the last 5 minutes, or you might be wanting to say, show me the trend for the last 3 years, so I can see how my energy usage in this January compared to last January, the last 3 Januaries. Or you might be doing it, how does this building compare to that building and so on. But in terms of a temporal axis, you can be doing it at whatever level and for whatever level of archiving you want. Like you can have it delete all records after a year, or delete after the database has grown to a certain size. You can have it have some sort of a window where it's only keeping or it's archiving at specific intervals. And then of course, if you're pushing it to something like Data Lake, you can do whatever you want there with respect to archiving or querying and so on.
Okay, got it. My last question, and maybe the last question, if folks, if you're sitting on a question, please submit it. Could you talk about the future development plans? What's sort of on the horizon for features for your product, your platform?
So yeah, I mean, there's lots, as you can imagine. I can't comment on or commit to what's coming when, but there are a lot of things that are on the drawing board, whether they are feature enhancements, at the very granular level, like can we add this sort of security, or can we add this type of store and forward, or can we add this type of protocol? They're very low-level things like that, or they're very high-level ones like can we offer a PaaS or a SaaS service that allows you to subscribe to a service as opposed to implement it in your own cloud subscription. So there are many of these, and we have customers that are in various stages of testing new versions of the software. We have a very large construction company in France that is testing a version using some very new technologies from Microsoft. We have other customers that are testing out integration with AI and ML and so on. So there's a continuous roadmap, and like all software companies in this space, you are trying to keep abreast of the types of scenarios that are coming up and how you're going to be able to apply the software in that environment. Whether it's remote oil rigs in the North Sea, or offshore wind farms, or new types of manufacturing plants and so on. So we're all trying to make sure that we are staying relevant with new requests, as well as keeping up with the type of scalability and so on. that is coming into play.
Perfect. Well, Spiros, thank you so much. We have managed to address all the questions, and we're actually at time as well. So I want to thank everybody for attending today. Thank you for your questions. Thank you, Spiros, for sharing the ICONICS platform with us. And I'll let you have the final word, and we'll wrap up. If you do have something you want to share, go ahead and type it in. Otherwise, we'll shut this down in another minute. But Chris, if you have something you want to sort of close with, the floor is yours.
No, I just love to get your questions. Sorry there were questions I couldn't answer, but I'll do my best to get you the answer. You know, feel free to ping me with additional questions over email if they weren't asked in this session.